Hey everyone, welcome to another episode of Black Guy Does Physics. Today we're going to go through something Miss Janet Pinedo asks us to do. That is systems of equations. Well, I guess today you could say it's Black Guy Does Math. If there are any physics problems that you want this black guy to solve, please comment below. All right, let's get it cracking. First things first, once you're talking about systems of equations, well, we have to know three different things. We have to know what an equal sign is, what an equation is, and a variable is. Obviously, you could look at books and get definitions from these, but if that was the case, you wouldn't be here with the black guy. So let me give you my definition. Equal sign, very simple. Left is right. That is, left is the same as right. Very straightforward. If you remember that, then you won't get lost. The left side is the same as the right side. Why this becomes important is due to the fact that you could then substitute. That means whenever you see the left, you could rewrite it as the right and vice versa. To the left, if you see, you'll see that Fly Kicks right there, which is a Nike Vapor Max 3, and it's $200. So every time you see this particular shoes, what you're seeing is $200. That is, I could replace that shoe with $200, or I could replace $200 with that shoe. You could use this for myriads of things. So for example, a classic example I would use in my class is that of a hamburger. If a burger costs $1, is the dollar a burger? The answer is yes. You can't eat the dollar, sorry. It doesn't smell like a burger, it doesn't look like a burger, but it is a burger. Why? Because it's equal to it. So mathematically speaking, you cannot tell the difference. This is a very powerful thing. You could use this for many examples in life or many things, but in life it doesn't work as well. It only works very well mathematically. Okay, next thing, equation. What's an equation? Well, an equation is anything with an equal sign. It's simply anything with an equal sign. There. If you have an equal sign in it, mathematically speaking, and it must be true, mathematically speaking, so let me put that, must be true for mathematics, then you're good to go. That's an equation, nothing fancy. The next one is a variable. What is a variable? It's anything used to represent a number. Now, I want you to look at listen to my words carefully. When I say used to represent a number, it doesn't mean that the number is unknown, man. I could know the number and give it a variable anyway. So for example, I could say 5 is represented by X, or 200 is represented by T. That does not mean I do not know what T is. I'm just using T to represent that number. So do not get it twisted. It doesn't represent an unknown number. The number could be unknown or it could be known. So just wipe that out your mind and put, it just represents a number. You see a variable? It's a number. You treat it like a number. That's it. The last thing that you need to know, and this is very important, that's why it's in bold red. When you have a systems of equations, for every unknown, that's the number of equations you need to numerically solve. I'm going to underline numerically solve. Lots of students don't understand what numerically solve means. If I write something, as I said before, let's say Nike equals 200. Well, that's a numerical value, therefore I have numerically solved for Nike. Now if I write Nike is equals to X plus P, that is also a solution for Nike. It's not a numerical solution because I do not know the value of X and P. If I wanted a numerical solution for X and P, for Nike, sorry, then I would need a numerical value for X and P. then I'll get a numerical solution for Nike. Let me go through that once again. This one, numerical value. So it's numerically solved. This one is also a solution. It is not a numerical solution, but it is a solution. Why? Because I know what an equal sign means. Left is the right. Therefore, if I have Nike is equals to X plus P, then I know what Nike is. And that's what you have to take in with you. Okay? So now we have the basis covered. Let's see if we could look at a problem that was posed by Ms. Pinedo. All right? And I think it is 3x plus y equals to 4 and 5x minus y equals to 22. Now, once you have this, the first thing you want to do, this is what I suggest, you're going to label the equation so you don't get confused. 1 and 2. Now, you're usually said that in your math classes, someone will say, go like this, and since the y's are the same, you could just add these equations and you get 8x, and that cancel out is equals to 26, I think, and then x is equals to 26 over 8. Yay! Nice and easy. Nice and easy. That's not what we're going to do. We're going to do this in a substitution method. Why are we substituting? The reason why you want to substitute is that it will always work. This method does not always work. Now, sometimes substitution might be longer than this method, but it always works. So it's necessary that you know this type of method. Okay? So here we go. Let's look at this problem again. It's 3x plus y is equals to 4, and 5x minus y is equals to 22. Let me move this up a little. So once again, label equation 1, equation 2. So you're going to, the first thing, and I'll write it out, the first thing that you want to do is that you're going to solve for one of the unknowns, or check how many unknowns you have. So I have 1 unknown, 2 unknown. And how many equations I have? 2. So that means I could solve. I can solve numerically. So the first thing you want to do is check how many unknowns you have, check how many equations you have to see if you could solve numerically. Once you have done that, then you're going to solve for a value of one of the unknowns. So I am going to solve for, y in equation, let's go in equation 2. I'm going to solve for y in equation 2. Good. Once I solve for, that's what I'm going to do. So if I'm solving for y in equation 2, that would give me, I'm under the impression you know how to rearrange equations. That would give me, I would move the y over here, move this over here, move this over here, and I'm good to go. So I'll have y is equals to 5x minus 22. Because once it comes over there, then it becomes a negative. And this would give me a solution for y. Notice it's not a numerical solution, but I know what y is. If I go back to what an equal sign represents, it says that left is the right. So if left is the right, then whenever I see y, I could rewrite y as 5x minus 22. So that's what I'm going to do. I am going to substitute y into equation 1. I don't know why I didn't solve for y in equation 1 first. It might have made my life a little bit easier, but oh well. Same difference. Once I solve for substitute, everywhere I see y, I'm going to put 5x minus 22. So that gives me 3x plus, I see a y, so I put parentheses 5x minus 22 equals to 4. Now I just distribute the positive sign times all of this is good to go. So I have 3x plus 5x minus 22 is equals to 4. Therefore, that gives me 8x. I move this over here. That x looks very crooked, everyone. Oh, handwriting is hideous. Oh well, 8x is equals to 26, and that would give me x is equals to 26 divided by 8, which is what we had before. Now, the question that you might have yourself, once again, why would I go through this long procedure? Because this always works. When you're doing math, it's always procedure based. Learn the procedure. Do not think about the answer. You learn the procedure. The answer is just a consequence of the procedure. Shout out to, what's that guy's name who said that? Oh, I can't remember his name now. But shout out to him. The answer is just a consequence of the procedure. Okay? So do that. So if you understand the procedure, you do not need to do 50 problems to see if you know what's going on. You just do enough problems and do the same procedures to get it down. So let's try another one. This is one I just made up. Let's see if it works. Okay, so we're going to look at another problem. This is going to be m minus 2p is equals to 4, and 3p plus m is equals to 10. All right, first things first, step 1, label equations. Step 2, check for your unknowns. 1 unknown variable, 2 unknown variable, 2 equations. So now I could solve numerically. Step 3, solve for one of these missing variables that you have here. I am going to solve for m in equation 1. Makes my life nice and easy. So if I do that, then I should have, this is going to be moved over here. It becomes positive. So that is m is equals to 4 plus 2p. The next step, I said that would be step 3. Step 4 is that you substitute m into the other equation. Because remember, you've already used this equation. So I put a check mark here to say I've used it. I don't want to confuse myself. The only one that is left is that one. So I am going to substitute m into equation 2. That means everywhere I see m, I write 4 plus 2p. So let's do that. So it becomes 3p plus m. Oh, crap. Everywhere I see m, I put 4 plus 2p. So that gives me 4 plus 2p is equals to 10. So therefore, I spread it out. 3p plus 4 plus 2p is equals to 10. That would mean that's 5p. I move this over here. That becomes a negative. Gives me 10 minus 4, which should be 6. So p should be equals to 6 divided by 5. And there you go. Oh, I forgot. Once you have solved for p, now that you know the value of p, let's put this in red or blue. Now that I know the numerical solution of p, I could just take it and substitute it here to find m, because I know what m is equal to. M is 4 plus 2p. So if I do that, I'm going to substitute. Let's substitute p into, I should have labeled this equation 3 into 3. And that would give me, let's see here, m is equals to 4 plus 2 times 6 over 5. And that would be 4 plus 12 over 5. I don't want to do any fractions, so that should be good. Now, we could do another example, but it's the same principle. In my next video, part 2 of this, you'll see more examples, a little bit more difficult. Well, there you have it. A basic, fundamental mathematical concept explained by the black guy who does physics. Well, please comment below, like, share, subscribe. Press that button, that thing that goes bling bling. Press the button, man. Press the button. And remember, kids, don't be a moo-moo.